Hello and welcome to another episode. Not every object in the night sky gives off visible light. This means they're not observable with a standard astronomy setup. One such object is CW Leonis, also known as IRC 10216. This does actually give off some incredibly faint visible light at magnitude 18, but if you look in the infrared, it shines roughly 10,000 times more brightly. This is because CW Leonis mostly emits energy in the infrared wavelengths. It is believed that this is most likely because CW Leonis is in the early stages of becoming a planetary nebula, with most of the carbon-rich shell of this star already being blown off, forming a nebulous cloud. I have read reports of some people with 22-inch telescopes and upwards saying that they can just about make out the nebulous bubble around the star, but not glimpse the star itself with their own eyes. This is what you should expect from a star that is mainly releasing its energy in the form of infrared radiation. So in this episode, I'm going to show you how to see such objects using near-infrared astronomy. I did a general introduction into near-infrared astronomy in the episode linked above. CW Leonis is also the closest carbon-rich star that has been discovered near us at 310 light years away. A carbon-rich star is one where there is more carbon in the star's atmosphere than oxygen. This causes carbon atoms to form carbon monoxide and absorb the remaining free oxygen, creating other carbon compounds that produce a ruby red colour in the star. While CW Leonis was discovered using a 62-inch telescope back in the 1960s, you can actually capture it through a telescope in your backyard. So to be able to see this, you need at least a 4-inch telescope, ideally a monochrome camera, as this is 3 times more sensitive to infrared light than a colour camera. You will also, of course, need an infrared pass filter. This blocks all other light except for the infrared, allowing you to capture an infrared image. To find CW Leonis visually is difficult, as the star itself is not visible visually. The best way to take an image of the star would be to polar align your telescope and move to the star using go-to functionality. However, to do this visually, you want to start at Regulus and then work along to New Leonis, then carry along in the same direction. Here is an image of the star field where CW Leonis is to help you recognise the correct area. But what is the actual difference between near-infrared and visible captures? Well, both of these images used about 3-minute exposures. The first image shows what you would see using visible light. Note that when creating this image, I'm using an infrared blocker, which would normally be used to make it easy to focus the image, because having visible light and near-infrared light together makes it difficult to focus. Now notice there is a very faint star here. This is CW Leonis. In the infrared, you'll see that most of the stars disappear except for a few, and this is because most of those stars are not so intense in the near-infrared wavelengths. Then, in the infrared, CW Leonis suddenly becomes quite brilliant. And as you can see, that is really something to be impressed with. You can do that in the back garden. That's all for another episode. Please leave a like if you like this episode. It really helps out the channel. If you have any questions, please leave them in a comment below. And if you'd like to see more astronomy episodes, then please subscribe. Goodbye and clear skies.